It's 8:30. We can go ahead and get started, let the stragglers run in. This is not going to be a normal presentation. I mean, based off of the crowd you see in front of you, it's never going to be a normal presentation. This is more of a audience participation discussion. Yes, we'd call our slides Problems with AI Interconnect or Interconnects, partially because all of us are, well, partially because of the buzzword AI, but mostly because, hey, how do we connect into these next generation systems that are going to need a lot more bandwidth, a lot more throughput? We have done the opinionated experts, I almost want to call it a series now, for the last 3 or 4 SDCs. They have all been birds of a feather presentation, but we wanted to do this in the morning instead, get more audience participation, and hopefully get more feedback. And that's where we're looking to you guys. Ask your questions away, get us a lot of feedback. We want to hear it so we can go and figure out what are some of the right things to do going forward. So to introduce your esteemed panel, we've got Mike Allison. He's the Senior Director of NAND and Product Planning and Standards at Samsung. We have John Geldman. He is the Director of the SSD Industry Standards at Kioxia, and he's also a SNIA board member. We have Paul Coddington. He's a mechanical engineer at Amphenol. He's my partner in crime as being a co-chair of the SFF TA, which is the group putting on this talk. And he's also a member of the SNIA Technical Council. And then myself, I'm Anthony Constantine. I'm a distinguished member of the technical staff at Micron. I'm co-chair of the SFF TA along with Paul, and I'm also a member of the SNIA Technical Council. Just a quick note on what our group is. The SFF, and SFF doesn't stand for anything, just going to lay that out there. I know a lot of people think it's small form factor, but doesn't mean anything. So, not anymore at least. So
that was at least 20 years ago.
Yeah, it was at least, yeah, it's been 20 years, so. So we are somewhere between 75 and 80 companies. I listed 76. That number fluctuates depending on the time of year. So I think this number is closer to 80 right now. We have over 150 published specs. And these are specifications, not standards. So, and they're ranging anywhere from connectors to cables to form factors to reference guidance, transceiver specs, etc. Our specifications are used everywhere. You'll see them in specifications for PCI SIG, JEDEC. You'll see them in OIF. You'll see them in ANSI. We're pretty prevalent. Matter of fact, in the last 12 months alone, we've published 5 new specifications. Actually, this number has gone up even. We've published 5 new specifications and revised 7 existing specifications. And again, this ranges anywhere from updating the EDSFF specification for Gen 6.0 to having new connector or cable releases, revisions, or having new transceiver specifications. Okay, so this is where the fun begins. Basic ground rules. This is an open panel. Please ask questions because you want to hear our opinions from our opinionated experts. If you want to really poke the guys, they all have strong opinions on PCIe 6 cables and connectors and higher speeds. The higher storage capacities and form factors. Matter of fact, Mike Allison and I were just talking about this a little bit ago. Lane bifurcation and lane counts, retimers, transceivers, or anything else you want to get our goat on. So with that, ask away.
Tell me about PCIe copper link and does it work for Gen 6?
Okay, so the question is PCIe copper link and does it work for Gen 6? So PCIe copper link is a PCI SIG specification. We have done the cable for that, and there's actually 2 specifications, right? There's the internal cable specification and there's the external cable specification. So both the...
I'm not correcting you, I'm just
Actually, you know...
waiting to see when you want me to speak.
Actually, that's a great question. So Paul, why don't you go ahead and explain this?
So the internal copper link cable specification done by PCI SIG is based on our SFF TA 1016 specification for the connector, and then there's also the external copper link cable specification done in PCI SIG that's based on our SFF TA 1032 specification, which is it's a variation on the old CDFP design.
1016, MCIO, and PCIe copper link internal are all the same thing.
Correct.
It's the mechanical versus...
The MCIO is really just sort of a naked connector. When you start adding in the additional requirements for where the side channels are and where the lanes are, you actually get into the what distinguishes a copper link cable from something else. Yeah.
Yeah. So
It is a use case for MCIO.
my company, Amphenol, has a variety of MCIO connectors, and some of which are part of the SFF TA 1016 specification, and that's what PCI SIG uses for their Gen 5 and Gen 6 copper link internal cable specification.
The internal will work for Gen 5 and Gen 6, but the externals for Gen 5.
No, that is also supposed to work for Gen 5 and Gen 6.
Yes. So to answer your question, yes. Gen 5 and Gen 6.
And they're working on Gen 7.
I have yet to see a single OEM in their specifications document cabling connectors correctly. Per what you just described.
So maybe that's feedback we can give to the
We
OEM.
wanted to do in the SSD SIG like a PCIe cabling guide, and we're like, where do we start?
Maybe we should help you with that.
We can help with
The
that.
effort that was started from the PCIe Optical Working Group that Sam Coxis from Amphenol is working on, all that work that could lead to unification of connector types. Instead of having Ethernet, use QSFP-DD and OSFP-XD, and they're both by 8 by 16. Can we find a way to get this industry unified on a high volume shipping product instead of re-architecting CDFD to have, single board connecting it to two boards or whatever, and then make it all fit into a different class of connector for PCI from Ethernet. Is there a SNIA initiative that we can actually start that maybe collaborates around a unification of that connector?
So the question to the audience is on SNIA optical, on the optical discussions that are happening in PCI, in the SIG.
OWG, yeah.
And what could, is there a path to SNIA trying to find a way to unify and make that happen? So, Paul.
I think that's a good idea, actually. I don't know. I mean, as far as the PCI SIG optical work group, they're going to attempt to come up with a form factor that fits their requirements.
That's what I'm afraid of. There's more.
Well, I would note that many of the people sitting up here in front and in the audience are probably both members of SFF and PCI SIG, and even attending the occasional optical meeting. And it would be well within SFF's capability to make a proposal at PCI SIG.
Yes.
Yes.
And we are working, one of the things that we've been working on is some of the legal stuff, right? We want to have an alliance agreement in place between PCI SIG and SFF. We've been working back and forth for a long time, and we don't really have a formal communication channel, even though we have been working together for some time. So we're working on that formal communication channel, but this is one of the topics that we are definitely interested in.
Yeah, I think, looking at it from an AEC and active electrical, connectivity to AOC, the needs for something that makes it compatible where you can still buy one style cable and use for extended connectivity, whether it's optical or copper, right? Retimers or redrivers or whatever we need to get over the loss budget issues of PCI. But
It is odd for what it's worth, though. It turns out there's multiple types of retimers, and we're trying to figure out how to count them well. Because optical retimers aren't necessarily the same thing as the physical retimers we have in PCIe, which have some kind of functional tasks to do that the optical retimers don't.
right, and there's also the initiative of linear optical solutions that don't use a retimer, right? That would reduce power and hopefully help us in the overall power budgets. So anyway, I think it's a good conversation, especially in light of Ethernet being ahead of us in terms of speed, ahead of us being PCI users of technology. So, and maybe we can actually still get our bifurcation. I see it on your list here. One of the questions that I have is how many people see bifurcation on cables, going the extreme bifurcation, is that beneficial for the industry? Or should we put limits on how much bifurcation we want to build in the cable?
So this discussion was, sorry.
Hey, John,
No,
do you want to? Hey, John, do you want to?
I have an opinion.
Do you want to repeat the summary that?
So part of the interesting question is about bifurcation in the scope of cables. And one of the points of view on that came from the PCI SIG group when we were doing it, trying to figure out how many styles of Ys and Ws actually made sense. And we gave up because it bifurcated the market too much. People want simple solutions effectively for the cables that work in more places and that just connect. One of the things that the internal cable is designed for is basically to provide the functionality of, here is a whole mid-plane full of connectors. I want to move that set of signals from over here to over there. And when you're doing that, that bifurcation can be happening on the mid-plane. And we've put in, and we're adding in the controls for the first time in PCI SIG at least. You'll see there's a new spec coming out, PCIe MI, which will actually provide some information about what's available and what can be configured in that world. So the cable would be whole, the work would happen on the mid-plane.
Yeah, we started, I chaired the extended connectivity work stream within the server team at OCP, specifically to refine the requirements of the industry within a platform like OCP. And we published Rev 1.0 of the requirements from the OCP members at least. Now, there were about 32 companies that attended and provided feedback, and I think all that is documented as if the SIG or if, what we did is we provided that, we did a presentation at the SIG, and then the question is, can we collaborate within SNIA then, take that as a requirement set instead of, waiting for people to throw everything in the kitchen sink, right? Like, I really think there's an opportunity here come out of this group that could help consolidate it, just because it's like you said, it's a lot of requirements out there.
We do have the power as individual members to make this, and note that, we're also willing to do this work because of the way that SFF is currently built and probably will remain in December. If you're not aware of that, you can ask us about the new member rules that are coming. Some of us are experts in that, and have opinions. But I think that is actually a good direction, and it's something that I personally would like to see.
Do you want to try to repeat what his comment was? Because I don't know that it got picked up in the recording.
Did you guys hear me back there?
Well, no, it's not you, it's the recording.
Okay.
Or it's not the audience in this case, so. Yeah. So the question was for some of the OCP work which is being done for compatibility requests to make a uniform environment for these high-speed cables, can those be taken as inputs into SFF and carried forward as an SFF specification initiative? And I think the answer is a resounding yes. I think that would actually make sense. I agree with my esteemed opinionated colleague.
But with that comes you coming to our group and doing the initiative, not expecting this group to understand what's happening out there. You need to bring it forward and bring that initiative in.
So the SFF rules are that, in effect, any three companies can start a project.
And we try to stay technology agnostic, right? I mean, we have some specifications that compete with each other directly. So that's what we try to do. What we're trying to do is get stuff committed to paper effectively. And so multiple people can go and develop around it. So, question?
So I had a question. I heard earlier this week with the fiber channel presentations that we're running into other negotiation times of like bring up times for a link of like 12 seconds, 18 seconds as they increase the speed and they're not even getting above 100 gigabits per second. Is this something that we're also running into in other buses, or is that something that's unique to fiber channel specifically because of the length of the bus?
So the question has to do with the auto negotiation that was brought up earlier this week in fiber channel and it limiting the bus.
The duration of time.
Duration of time, excuse me, that's limiting the effective bandwidth of the.
No.
No? Okay, I missed that. Sorry.
It's the amount of time it takes for the link to come up and do the link training and all that to get everything up and running. Once it gets up and running, they're happy with the speeds. It's just the time it takes to get everything up and running initially.
Taking 18 seconds for PCIe link to get established. That doesn't sound good.
So that is not, so at the current speeds of that are in the labs for 64 gig of PCIe, that's not happening, that I'm aware of.
So that's an issue with fiber channel as far as if a cable gets unplugged and plugged back in, it takes a while for it to come back up, right? If a device gets rebooted, not only do you have the time for the device to come back up, but then you have that additional lag, which it's not a latency that you see all the time. It's just when these events happen. And that's a nature of the fact that they are, backwards compatible for multiple generations of fiber channel as well. So
That's true for PCIe also, right?
There's actually multiple factors going on here, and I haven't seen or heard of this, but I'd wonder about just how what the gain on the PLLs are. I'd wonder exactly what algorithms they're going through to figure out. In PCIe, we have created some rules for skipping some transitions. You don't necessarily always have to go from 1 to 2 to 3 to 4 to 5 to 6. You can actually go from 1 to 4 and then see where you go from there, as an example.
But it's not something you see in PCI.
No.
No, it hasn't been.
And by the way, I can't imagine in a fiber channel environment that much dead time being acceptable.
Well, and right, and so Fiber Channel is working on 256 gig fiber channel currently, and so in that work, they will, they're going to be trying hard to keep that from getting any worse, and I imagine they will, make some attempts to try to make it better as well.
I will throw in a free opinion, as opposed to the other ones, that, by the way, you should not be worried about PCIe 6.0. You should be worried about PCIe 6.3, which will soon be on a shelf available to all PCI members, because there are multiple A-level errata which have been fixed in 6.1 and 6.2 and are still coming in 6.3. And so the A-level errata are what we all depend on getting fixed so that we are all interoperable. So when you write those specs, don't write them for 6.0, write them for that latest dot number.
Do you want to talk about lane counts and how storage is kind of bifurcating on compute versus storage? Like lower speed storage versus the high speed stuff, and you don't really need 4 lanes, 7, whatever, Gen 7, and they'll save power and cost stuff too.
So
Repeat the question.
Yep. So the question was about bifurcation for storage needs and what's really needed for any given device. And I will confess, I've heard multiple things, but a lot of the bifurcation push is actually coming from the root makers who have a wide port which they want to split into smaller and smaller groups. There are interesting tools coming in PCI 6, and they start in 6. The L0P is a really fun power-saving tool for copper, where basically without losing a beat, so there's no there's no transition time, the system doesn't stall when you change from one lane to however many lanes you actually need. So there's going to be a capability in the future so that if you do want to spend the lanes for when you need them and not use them all the time, that'll be a new capability for us to understand and tune in the data center. In the meantime, we're building systems where we have a substantial amount of performance which is available, and it can sometimes be it can saturate less than the number of connectors we have. And in those cases, potentially the device can be shared. And that is perhaps going beyond the dual port capability, which is designed into multiple SFF form factors and connectors today, and PCIe connectors. And that is an open ground for this type of solution to also create, is the ability to have 4 controllers in an NVMe 4-lane device.
At FMS, Microsoft announced that they want to use that feature for power savings. So when they need low bandwidth, they can lower the number of lanes being used, and when they need a lot higher bandwidth, they can adjust it dynamically to take care of that. And they basically said, hey, everybody, we want to do this, go make it happen and make sure you do it. And they were announcing early on so you could start thinking about it going forward. So.
Question?
What do you expect to change with CXL?
question is what do we expect for the change for CXL for PCI 6?
Well, I'll say from a protocol point of view, not much. Pretty much everything just still works because it's there. The interesting part about CXL today, from my perspective, is that you could absolutely build a device which does both, but it takes a personality on power on. And it doesn't switch in between packets. So you have to kind of commit during your bring up about where you're going to go. And having devices which can support that is technically feasible.
One thing that did come into play with CXL recently was LED management, because CXL is coherent, and unplugging a coherent device is not good. And recently we had a good go around where if the device could be either a non-coherent device, a PCIe device, or a coherent device, a CXL device, and they can plug into the same slot, how should the LEDs behave so that user won't go up and unplug a coherent device while it's in use? Whereas with PCIe, you're hot pluggable, and some devices are now not hot pluggable. And the platform vendors were doing an analysis of that kind of LED management. And by the way, did they ever finish that?
Yes, they did. And unfortunately, you'll see that in the JEDEC, you'll see the LED management in the JEDEC CXL form factor specs, and which was based on extensive UI testing by system houses, because nobody really understands what does a white blinking light mean? What does a white steady light mean? Nobody has a preconception, and the idea of what are the preconceptions and what can we actually get what do we expect what system operators actually will do in response to this that they haven't seen before and not get it wrong on the first time is what a lot of work went into.
And
personally, I would have preferred to see one moment. I would have preferred to see that in SFF rather than in JEDEC, but I lost that battle.
And
well, I think it's spec'd in the wrong place to be a general. It's really specific where it is on CXL form factors developed by JEDEC. That's not a good place for that kind of standard, in my humble opinion.
And to correct John a little bit, it's called the JEDEC CXL memory module specification. So that's in JEDEC. So that would be the specification that calls out that management LED.
And by the way, later we'll have a poll on whether it's JEDEC or JEDEC.
But just to understand the complexity, right? When we're talking of LED, we're looking at one product, right, in his LEDs. And what the platforms are saying is, I have this rack of all these things plugged in, and how does my IT guy get up there and figure out what to do with these large number of LEDs blinking and whatnot. So they're looking at it from a different perspective than maybe a vendor of just how do I blink lights. So it's a complex situation, and when it came in, it added a lot of conversation within the committee for LEDs, which happens quite a bit when it happens.
Yeah, everyone's very passionate about their LED conversations. It's something that has been brought up.
Which one of your SFF specs has all that LED information?
You know what? We have a few SFF specs that have LED information. Yeah.
Yes.
So what I was really wondering is, do you expect changes in topology, that 4K endpoint, more peer-to-peer network, possible to CXL, right? So do you expect that there'll be longer cables, more demand for external connectors on servers?
Do you want to?
Want to try to repeat that?
So the question is for CXL and its pooling, what sort of cable influence do we expect to see in the products?
I should have an opinion on that.
You should. So I confess, I may have an opinion, but it's probably not grounded on product requirements because it's not really where I normally play. But one of the interesting things that CopperLink provides is 2 sets of cables. One of them is that sort of mid-plane, that host to mid-plane conversion, which I talked about. The external has a very different flavor in it, where you actually take 2 boxes and hook them together. Yeah. And I think that's more of what's going to be interesting for the CXL world.
Yeah, it's the in-the-box, it's the in-the-box cabling versus the sled-to-sled cables that has been the differentiator there. But I don't know if anything changes going to CXL necessarily for the cabling. So, I mean, a lot of those cables were designed around PCIe. So if they work for PCIe, they should work for CXL.
Yeah, it would probably depend on the sideband requirements.
Yeah, if there's any additional but I don't believe there's been any additional sidebands. The CXL consortium has not brought up anything.
I have an opinion on that, but.
Perfect.
You're allowed.
So, from a CXL pooling perspective, it has to make sense from a TCO equation to pool at similar cost of expansion CXL.
Yes.
In order for us to do that, the current premise that a server has to have a chem connector or an AIC connector card in order to go out for the sheet metal and then face, a CDFB or QSFB or whatever back. There's an added significant cost in that server that the motherboard should have native sockets that are pretty cheap in comparison to the module, right? That would eliminate having another disruption in multi-connector and board, etc. So how do we go
Don't go
about?
too far because we're going to have to repeat this.
Okay, well, anyway, it would be nice if we have microphones, we can turn around here.
But why does, why, go ahead, John.
Well, let me first say that part of the, I think where the request was coming from, or the question was coming, or opinion was coming from, was we need to put support for these new cables straight into the system so that we have less reflections from the odd chem connector, which is not causing us any joy as we work at these high speeds. One of the interesting things which is going on in the optical world in that space is that the electrical, the way that the optical stuff is being measured is very strictly to the endpoint of the optical transceiver and not across the optical cable the way it is with CopperLink. Mm-hmm. With CopperLink, it's an end-to-end. With optical, it's a PCIe or CXL to the optical transceiver, and then it goes into a no-C mode for the optical until it comes out on the other end. And then you again have a electrical connection from that point onwards. And part of the magic, which is part of what may have fun in when we get into serious pooling, is the magic distance of optical of 10 meters, which is more than you're going to get out of copper. That's going to enable more significant pooling.
But I think, going back to your earlier point, we need to get stuff out of the way, right? I mean, we can't go from connector to card to distance to connector to another connector. I mean, we need to start eliminating things out of the topology. That's number one if we want to get any faster on copper, right? I mean, optical, you solve some of these problems, but if you want to get any faster on copper, I mean, I think we've learned that with the transition to Gen 6, right? You'll see like in the I think it's the 1016 specification, we added a, I can't remember the exact term, but we cable into an orthogonal connector such that we actually get rid of, instead of having a 3 connector topology, you're now at a 2 connector topology to connect from, system to SSD. So, I mean, these are some of the things, these are some of the tricks that we're going to have to use, especially if we want to go beyond Gen 6. So.
Again, another.
So, Randy?
So you're talking about removing things from the topology. One of the things that I've been thinking about is that PCI is generally from a CPU to a device, or from a device to a device. What about using it for a communication link between a CPU and a CPU? Like, not trying to make it like a multi-node system, but more like a multi-computer system, like a high availability node.
Well, so,
PCI, the problems that we've seen with it is that you're dealing with the pure conversation on the root side, and that the fault isolation is not particularly good.
Yeah.
But I was wondering if we were going in that direction.
So I will note, so one of the things that is enabled by SFF, the external copper link cable, doesn't have the assumptions of who's in effect the root and who's and many of the signals that are passed in the internal cable of how do you actually get all of the individual sideband signals out to the, as an example, four sets of 4-lane connectors, that's just absent in the external connector. And that's actually, there's a spec being developed in PCI SIG called ISB, in particular to honor that bring up and responsibility. That actually came out of work from the automotive market, and it's applicable there, but it's just as applicable to box-to-box communications.
So hopefully from your,
On a protocol level, it would be addressing the root-to-root conversation.
Yes. That's actually where I'd look for the rules for that is.
You might want to repeat that.
Oh, so thank you. So where are the rules for boss-to-boss talk coming from? Because nobody's willing to be in the you're fired mode. So resets are you're fired. And the response to that is PCI SIG's ISB, the I don't remember what ISB stands for. Oh dear. Inter-system bus. Thank you. Yeah.
actually, John Michael, do you have a question first, or?
I was going to hit on your second bullet point there, higher storage capacities and form factors. There was a slide in one of the keynotes at FMS from Meta that described, hey, maybe the current form factors for high capacity QLC, like E1.L or E3.L, may not be suitable for all vendors. There's some vendors that may be talking about like super high package count or non-standard packages. Or as we talked about this in the SSD SIG a little bit, and the consensus was, please, for the love of God, do not make any new form factors for SSDs.
But where's the fun in that?
Yeah, that being said, if there is some desire, it seems like the current form factors could hit 128 to 56 terabytes, in the next 2 to 3 years. Is there a desire to do something bigger?
So let me restate the question. So the question's around the higher storage capacities and form factors, and how do we prevent from doing another form factor effectively? I mean, we've got, it's funny because I was thinking earlier today, we've got, I think between 5 and 6 knobs right now to get more capacity into a disk. Obviously the first one is node shrinkage, shrink the node, get more bits on a die, okay? Make the die bigger, right? Those are the 2 die ones. And then you go to the package, right? Which is where I think one of the things we can do is maybe get agreement on package sizes that we do for any future, specified studies or, future form factor studies. So, there's die count in package, right? And then then we've got the form factor knob, right? How do you hit, in the existing volumetric, how do you stick more packages within there? And then the last knob, which is the unfortunate one, is do we need to grow the form factor? So I think we need to kind of have a conversation around, at least from a packaging perspective, how do we kind of get together? Because, yeah, there is demand for higher capacities.
Yeah, I think the assumptions going into when E1.L form factor was developed was optimizing for capacity per rack unit.
It was.
And it was not necessarily a capacity per individual drive. It kind of ended up that way, but
Correct.
And those kind of conversations need to be had. I think there was a desire to have some of the SSD vendors come into the SSD SIG and say, okay, here's what we see as far as like what our max capacity would be on these form factors. Does everybody think that that's okay? Or,
But there's another part to that equation is we need the platform vendors to say where are they going with their platforms and what kind of cards do they want plugged in. And we're already talking about 256. What about after 256? So if we don't start talking about something now, how do we be prepared for when those discussions happen for the 5-year planning coming out that you have to start doing stuff?
Yeah.
So, now is the time to say, where do we all want to go as an ecosystem? And does what we have meet? Are we going to shrink in time to fit within there? Our power budget's going to live in there? What's the next thing? And this is the group that says, let's be forward-looking and figure out what we need to do. So we need platform vendors to come. We need SSD vendors to come and CXL vendors to come. The other thing I want to point out is another thing that happened for the types of products that are supported, at least for E3. We made a recent change where the spec used to say, hey, here's areas on the form factor where you can put labels, and by the way, you shall put this label here. And we've recently changed to say, here's where you can put labels and not dictate the type of labels that could go there, because we were getting requests that people wanted to change where the labels were for different products, for different thermal problems or whatever. So another thing is to consider when you look at our specs now, it's just label areas, and we're not putting on the requirements about what label goes where anymore. It's just where you can put it. So that popped into my mind as I thought about your question about the different types of products that we've done recently.
When we did the EDSF work, 7, 8 years ago now, we were trying to find that balance between system and between system and NAND, or between system and SSD manufacturer. And it's not an easy balance, right? Because the system manufacturers have kind of their own ideas of what they wanted to use. I mean, this is why we ended up with so many form factors, right? To begin with, right? Is that there was, it's trying to find that balance between, what people can tolerate. Well, we're getting to a point now where, okay, we all know we need to go to higher capacities than where we can do with maybe a node step alone. And so what do we need to do from what do we need to do to maybe, do we need to grow Z? Do we need to, talk about, like I said, the NAND packaging and try to get a common footprint there?
So I will confess, we aren't the only opinionated people. And it turns out I've heard lots of comments over the last couple of years about why U.2 is a better platform than E.3. Lots of opinions. And these come from different spaces. As an example, it's relatively easy in a U.2 to build a 3-board system inside where you can put in lots of packages. You aren't constrained as to where the edge connector is that we use in E.3, which actually has some limitations to what we can do internally. And there are some people who have that preference, and they've made it known. And that's part of what, when we talk about some of the things that are actually important is how do we actually design our spacing in? Where do we put in the edges compared with the view of, by the way, we want to put in gobs and gobs of packages in there.
That's also a good point of, I know PCI 6 stance on U.2 and Gen 6 was nobody's asked for it yet. I think we would definitely like to see a stronger statement as of like, there will definitely not be Gen 6 on U.2 would be a much better statement for this U.2 to EDSF transition.
Well, if there's going to be, they better have a meeting soon.
Yeah, and I think you'll unfortunately, saying there won't be is kind of anti-competitive.
Yeah.
That's something we can't do, despite our opinions. We get in trouble for having those opinions.
Well, and there's going to be other conversations too, like like even the connector thickness or the board thickness. When you go to a card edge connector, you have to define your whole PCB generally around that. So, do we have enough layers to route out to all those different sites? It gets to be a very complicated equation.
We are down to, I think, the last 5.
We are. So do you want me to?
Sure.
Well, let me go through just the last slide, which is, I love all the questions out here. 2 ways to do this. Either bug one of us on the panel, or come to SFF and give it to us live. You can find out how to join, public site, all our specifications. But yeah, if you have any additional questions, email TWG chair. That goes to Paul and I, and we're generally decently responsive. So, but we try to bring up all these questions then into any question we get on there, we try to bring into the SFF group in general. So.
We also respond to requests and things that come into SNIA's feedback portal.
Yeah, so there's multiple ways you can get a hold of us, but please, we're an 80 member company or 80 company membership, and we're trying to do the right thing at the end of the day. So, we need your guys' input, feedback. So
7 a.m. Friday mornings, Pacific time.
Not this week, though.
Not this week, though. 10 a.m. Eastern.
If you live in Colorado, it's 8. It's not so bad.
Last.
Is it JEDEC or JEDEC, and why is the other one wrong?
You want to repeat that question?
No. So
I think you can. We'll head to this one offline. Thank you everyone for attending. So.
Yeah, thank you. Yeah.